Welcome back to the lesson. Let's continue. Now we will review job plan activity scheduling. A question to consider: what is the difference between planning and scheduling? Planning identifies what needs to be done. Quality planning is the basis for a successful scheduling effort. Comprehensive job plans define scope and resource needs. A poor or incomplete plan cannot be developed into a successful schedule. Scheduling defines when it is to be done. It identifies and quantifies project risks, execution, timing, and resource usage. It is the basis of controlling project results. It controls final duration and total cost. It determines whether time and money are made or lost. A good plan can be poorly scheduled. Effective scheduling is the process of organizing work, meaning activity or tasks, and resources, meaning labor, material, and equipment, within a defined time frame. Activities or tasks and resources should already be defined in the individual job plans. Scheduling takes information and adds sequence, duration, and timing. It also defines the timing relationships between individual jobs or groups of jobs. Scheduling job plan activities include the sequencing of work, which is based on the flow of events for each job plan. Some steps must happen in series. An example is blind, remove head, pull bundle, transport bundle. Some activities can happen in parallel. An example, clean bundle and clean head. We will now review scheduling methods. Critical Path Method, or CPM. This is the most widely accepted scheduling method used for turnarounds and construction projects today. The remainder of this course will be based on the CPM scheduling approach. Basic steps for CPM. Define the logic. It is reflected and reviewed using a network logic diagram. It depicts the relationships among activities. It calculates the start, finish, and float times. It identifies critical and subcritical paths. Take a moment to review the chart below that is an example of the precedence diagramming method. It defines each activity to complete before the next activity can start. There is the common finish to start. There is the start to start. There is the finish to finish. And there is the start to finish. Take a moment to again review the chart below, and you will see the example of predecessors, the activity in focus, and the successors. Predecessors are activities that precede the current activity. Successors are activities that come after the current activity. The forward pass calculates an activity's early start and early finish dates. It starts at the beginning of the schedule with all activities without predecessors. It is determined from working forward through the logic network, resulting in the project end date. The early start equals earliest time at which an activity can start. Early finish equals the earliest time at which an activity can complete. This slide gives an example of forward pass calculations. Given that activity A starts at time unit 0, activity A has duration of 8 time units. Activity A is the predecessor of activity B. Activity B has duration of 6 time units. The forward pass will show early start and early finish times for activity A and B. The early start for activity A is time unit 0. The early finish for activity A is time unit 8. Early start for activity B is time unit 8. Early finish for activity B is time unit 14. Forward pass calculates an activity's late start and late finish dates for the uncompleted activities. Backward pass begins with activities without successors. It is determined from working backward through the logic network, resulting in the project end date. Late start equals latest time an activity can begin without impacting the project. Late finish equals latest time an activity can complete without delaying the project. Here is an example for determining backward pass. Given that activity A starts at time unit 0, activity A has duration of 8 time units. Activity A is the predecessor of activity B. Activity B has duration of 6 time units. It will show late start and late finish times for activity A and B. Late start for activity A is time unit 0. Late finish for activity A is time unit 8. Late start for activity B is time unit 8. Late start for activity B is time unit 14. Float. Total float equals late start minus early start. The amount of time that an activity can be delayed without delaying the project finish date is total float. The difference between an activity's late dates and early dates is its total float. Example, total float is 0. Activity A and B are also the critical path. Critical path is the path of activities that, if any one of them is delayed, results in a delay in project completion. Scheduling exercise. Use the information provided to complete the scheduling class exercise that follows. Here are the answers to the class exercise. To continue your training, please click the button below.